Hello there, everybody. Welcome BLS022 Show and Tell with CHAU TRAN. Ciao, how are you doing?
Good. How are you? Thanks for having me.
I'm good, man. Thanks for being here. I guess for those of you watching CHAU, neither CHAU nor I do really need an introduction. If you do want to get to know CHAU a little bit better, you could always follow him on Twitter, which is Nartzy1410. Or check his GitHub and then do him a favor and start his repo, github.com/nartzy/mapper. And this is the repo from the product that we're going to talk about today, which is the Automapper for Nest.js, which, if I say it right, is a re-implementation of the Automapper for .NET, but then in the TypeScript ecosystem or JavaScript ecosystem. And there was, I think it's a version 1, right? The current one, which is the current Automapper.
Yep. I'm going to talk about a little bit of history for Automapper and all of the implementations of an Automapper in TypeScript or in JavaScript that I know of. Then we're going to get into the Automapper that I wrote.
Okay, awesome. Very cool. So one of the things it's going to be a practical and quite a technical session. So for those of you interested in how everything works like this, keep hanging on. Fun fact is that start of 2020, I asked on Twitter if somebody could help me understand decorators because I couldn't understand it at all. And I wanted to do some magic TypeScript stuff. And the thing we're covering today is exactly explaining how this works. So I'm super excited about this. Gonna quickly say hi to Serkan, who is here. Serkan, good to see you, man. And Abel de la Fuente as well. Always nice to have you around. So super cool that you guys supporting me. And I think with that we can get started. So let's share your screen. And I think, I think that'll be it.
All right. So hi everyone. Welcome. And today I prepared some slides to keep me on track. And the slide doesn't have any information. I'm just trying to wing it. But today, this is going to be about Automapper in TypeScript. And the agenda is I want to go over a little bit about what is object mapping and what is Automapper and why does this exist. And then we're going to go into the problems in TypeScript. And I'm going to talk more about the problems in TypeScript when we get to that section. And finally, we're going to talk about Automapper in TypeScript. And then last but not least, we're going to have a Q&A if we still have time left. So first thing first, object mapping, or sometimes it is called a transformation or object transform, whatever you want to call it. It's just basically the idea of mapping from one object to another. You see this a lot when you use like an ORM or ODM. So like Mongoose for MongoDB, or like type ORM or type ORM for SQL or relational database. So basically you have on the left-hand side, you have like a class with some property name and you want to map these into a language or into a concept that a database implementation can understand. So in this case, it's just map from ID to student ID to the ID here, first name to F name here. So this is one idea of object mapping. Another idea of object mapping is when you have some data transfer objects, or short for DTOs. So DTOs will be used on the presentation layer to display or to expose to the client. And sometimes you don't want to expose the business logic or the business models on the presentation. Let's say on the user, you have a login and then you have the password. But then when you expose these models, you don't want to include the password when you expose these models on the client. So we have this type of object mapping as well, from business models to presentation models. There's a lot of names. So you have DTOs. You have view models, and you have presentation models. And then on the business side, you have business models, you have entities, you have demand models. So all of that is the same thing, from mapping from business models to your presentational layer. And the Automapper that we're going to talk about today is to target this type of mapping, is to map from your business model to presentational model. So what is Automapper? Automapper, we have the original Automapper from .NET. That is the .NET Automapper, or you can go to automapper.org. This is the OG of Automapper, created by Jimmy Bogart. So if you're interested in the concept of Automapper, look up Jimmy Bogart, and he writes a lot of blog posts about Automapper. I'm gonna bring these into the chat. Actually, I cannot, so I'm gonna chat you privately.
Yep, I'm gonna share those.
Where do I go to chat private? Right here. I saw a private chat. So that's Jimmy Bogart, and this is Automapper link. So the Automapper, the mapper part is what object mapping is doing. The auto part is what we're going to have to put the work in for that auto. And the work is we're going to map by convention. I'm going to get to like the demo when we talk about a convention when we get to the demo. And because it is by convention, so it is very opinionated. Some people might love it, some people might hate it. Why? It will alleviate the boring task of mapping from demand models to your view models, because sometimes your view models are basically the same as your demand models, but it just excludes some field. But for the fields that you want to include, you still have to map them. Without an Automapper, you have to do that manually, or you have some like reusable functions that to do those. It's still the code that you have to maintain. With an Automapper, you can have separation of concerns, which means that now you can the Automapper will take in a configuration, a mapping configuration that you set up beforehand, and now you can separate these mapping logic outside of like fetching the data outside of the model itself. And we want to promote a convention over configuration. So if you, again, we're going to talk about convention later. So now I'm talking about Automapper. I'm going to do a quick demo of the sense of what is the mapping or the mapping configuration. So I'm just going to pop up the console and do some live code here.
Can you bump up the font in the console a little bit?
Yep.
Yeah, awesome.
So assume that you have a user object, and the user will have like a first name. I'm going to put it CHAU. Oops. Look at that. Redo. Redo. So we have a user, right? User one with first name, CHAU, last name, TRAN. This is my name. I have age, 29. And let's see, I have some profile, and on my profile I have a job of developer, something like that. It's pretty simple. And on my user, I will have password, right? 1, 2, 3, 4, 5, 6. And now I want to map from the user to user DTO, and my user DTO will have some field like I want to have the full name. Right. I want to keep the first name, last name, but I want to have the full name. I don't want a password. I don't want the age, but I want to know if I am an adult or not. And I want to have my job. I don't need the whole profile. I just need a job. But this is my user DTO that I want this information on my DTO. So the first thing first is you're going to have to set up some mapping configuration. So I'm going to call it app config. And this is just an object. And let's say for first name, we're going to map from first name. Actually, let's just make it into one type for config, which is a function that takes in the source. So the source will be this user one. And for first name, I want to return the first name on the source. And same thing here, source.last name. For full name, I want to do source.first name plus source.last name. For the user node, it's going to be source dot age greater than 18, and for job, it's going to be source dot profile dot job. Right? Oops. Oh, I missed the plus. I missed the plus right here. There we go. So now I have the map config. I have the source object. So assume in your code, you're going to get the source object from a fetch user from DB, for example, after the user logged in. And now you want to return to your client. And we want to map this over to the DTO. So I'm going to have my user DTO as an empty object here. Then I'm going to look over the key on the map config, right? And for each of these key, I want to assign that field, that key on the user DTO, and I'm going to grab the map config as the key, and it is a function, and it has in my user one, right there. And now if I log my user DTO, I will have the map config of the map for the map data from the user one to user DTO. And this is a sample map config. Now Now your job is now to make this into a generic one so you can do different models and to support more like condition. What if age is not greater than 18? You do that, or you want to ignore something, or you want to do you want to have some like nested. So let's say in profile, and you have more stuff in the profile, and you want to nest it, map these over to a different type. It gets hard when you want to do it manually. So that's the job of Automapper, and that's our job. Right. So, any questions so far?
I don't think we have any questions. I do. If you can pop open terminal, I'm not sure if it's still there, but no, it left. Anyway, I think a lot of us developers have worked with a very similar structure, but implemented it more imperatively. I know I have done so. For instance,
what do you mean by imperatively?
Doing very similar like what you've done. So not declare the desired behavior and run it through a tool, but basically write your custom converters.
Actually, I'm gonna grab a quick example from the docs that what we actually did before we have an Automapper in TypeScript. I'm gonna bump the fonts up a little bit. So let's assume that we have these classes, which is our entities, models, and stuff like that. We save these models in the database. And on the DTO, we will have the static method that we're going to map from the entity over to this DTO and return that DTO. So whenever in the code we want to return a user DTO, we do user.dto from user, something like that. And we might have a lot of different static method to map from different models to this user DTO.
Yeah.
So this is what we did actually. But then the problem with this is now you have the user DTO knows about the user inside of the user DTO class, and all of these like first name, last name, you might have a duplicate method. And what you do if this user DTO extends another class. So that's one case that's another approach rather than the map config approach.
Yeah. Yeah, but I think in any case, if you've worked with like an external API or a system where you indeed want to hide certain fields and leave the other ones, or morph a structure into another shape, what you generally do, or what I at least generally do, is create some like normalized functions. That's how I call them, and then run them through it. But the fact of the matter is, it's not at all scalable, because it's a lot of work to do it right, and you basically re-implement part of the same logic each time again. So this is the thing that Automapper solves.
Yeah, and now we're gonna get to like a very comprehensive example from when we get to the Automapper core of the TypeScript part. So that's all the demo I have for Automapper, the concept of mapping. Next, we're going to talk about problems in TypeScript. And as you guys know, TypeScript is just a subset of JavaScript, and JavaScript has dynamic typings. And because it has dynamic typings, the reflection capability is pretty weak. And what reflection means. So if we look at the TypeScript lang playground, actually, there we go. Console that out. I have a class foo here.
Can you bump it up a bit?
Yep, I'll do that. Let's close that and let's close this. Is this good enough?
Yeah, perfect.
All right. So what reflection means is that if I look into the foo class, actually, if TypeScript looks into the foo class at runtime, actually reflection is a runtime thing. At runtime, I want to know that foo has a property named foo, and the type of this property is string on the foo class. And the problem here is that if I would do new foo, and do console log foo, I'm gonna bring this to the bottom, right? And I run this. You see that foo is actually a foo class, but it doesn't have any information about the foo right here, the foo property on the class, and that don't have any information about the string as well. So that's the problem with TypeScript that we have to solve. And because the auto part is very based on the metadata of the class, so these properties and the type of the properties on the class is the metadata of the class, right? The class is data, and then that data has data, so it will have metadata on the class. And how do we solve this? We do something called a decorator. We're gonna append, or we're gonna decorate this foo with some decorator that's gonna save the information of this foo property on the class foo. And real quickly, I'm gonna return my code here that I prepare. So a decorator has a couple of type of decorators. We have a property decorator, we have method decorator, we have class decorator, and we have parameter decorator, I believe. So we have these three, and then the property decorator. And the class decorator will go on the class. In this case, I would love for the class decorator to be able to look for all of the properties of that class, but unfortunately, it's not the case. It cannot. So I have to use the property decorator. And when you write a decorator, it's very simple. It can be a variable. It can be a function, and that function or that variable has to return the type of property decorator. And a property decorator is a function that takes in the target and the property key, and that's it. You can do whatever you want with the target and the property key. What is the target? So when you have this decorator and then you attach a decorator on a property, remember this is a property decorator, on a property, the target will be the foo constructor. So this foo right here will be passed as target in the decorator, and the property key will be this foo property right here. So if I run this right now, you can see that the target will be that foo, and the property key is the foo, because that's what I console log right here. And how decorator is going to help us with storing the metadata. And because if you look at the JavaScript compile code of that decorator, TypeScript will have, when you have a decorator attached on, at least one attached on a property, then TypeScript will generate this decorate function. It will also generate a metadata function. Then at runtime, it will generate a function. It would call that decorate function. It pass in your decorator, right there, decorator, and it would try to get the metadata of of this property, you can see that it knows when I say the string, it would know that the type of the foo is a string constructor. So this function, you see that it gets called right away when it runs your code. So it will always run first. The decorator will always run first before anything in your code. And that's just decorator. It's just decorator.
So
coupled with, I'm sorry, keep going.
I think to summarize it, in TypeScript, which is a develop time environment, we have the knowledge of string and we can do stuff with it. But when it gets compiled to TypeScript, types drop away. And in order to do something with these types, we need to basically store them somewhere. And this can be done by decorators. And we can add a decorator, and this allows us to do anything like storing their types and doing something with these types.
Yep. So now I just added a bar property with a type of number. You see that number is lowercase, so this is a TypeScript type. But then reflection, reflect metadata, we'll be able to infer that the number type will be the number constructor, and number constructor, this is an object. Like it has value in JavaScript. So it will know now my foo class has information about a foo property and a bar property. So when I do a new foo, I want to get an object with the foo and the bar on it so that it has some metadata that I can work with. Is metadata required for an Automapper? Yes. Is metadata required for a mapper without the auto? No. The metadata only comes in when you have some auto part in your mapper. So that's all there is to the decorator. All right, let's get back to.
And I can imagine like the other, so there's a property decorator, which you put on a property. The class and param decorator and the method decorator are very similar in their behavior, right? So they get tagged on some of the properties or some of the parameters.
Yep, so I'm gonna do the same thing right here. Actually, if I run this right now, if I run this code, you see that it logs out a target, it logs out a bar. But if I get rid of that, I'm gonna call my decorator. Normally, I pass in the constructor. I think it's prototype actually. Constructor. A prototype dot constructor. Oh, forgot. Sorry. That. So it's going to be foo, not prototype, and I pass in the bar, and I run it. It's going to be the same thing.
Yeah.
So basically,
just a method that executed.
It's just a method. Yeah.
And another thing that took a while for me to understand is that there are decorators that don't even need the parentheses when you invoke them. So some of the decorators, not sure what the difference is.
So it's just nothing different, because I have a decorator here, so I can have my argument that I pass in if I want to have an argument. We can just have a constant called decorator constant, and this one with just a property decorator, and it is function, right? Probably key, and it's going to do something, and then you can just do decorator const without the method.
Yeah, very cool.
Yeah.
And I think Serkan has a nice thing to add at this point. When you add a decorator to class and property, the property decorators will be first called, and then the class decorator. This is
that's a good point. That's a good point.
Yeah. Good to know if you want to know that all properties are executed. Great. Thanks for the input, Serkan.
Yep.
Appreciate it.
So right there, I'm gonna put it back. Right.
Awesome. So this was my missing induction to decorators, what they are and how they work. So I think this is super valuable as a standalone already. So what's the next thing we're gonna do?
Yep. And the next thing I want to talk about is inconsistent metadata with different TS config. So when you set up your TypeScript project, the TS config actually affect the metadata. So to demonstrate that, I'm going to have an enum. So let's say I have an enum of row. Let's just call it. It's going to be red, blue, and I have a color here. And now I put decorator on this one, and I look at the JavaScript. you see that it knows that it's a number, enum. And then if I change, if you have like some TS config that like transpile only or something like that, it will not know about that TypeScript at all. So I cannot demo this here because the TypeScript playground doesn't actually have the TS node or any TS runtime. Not TS runtime, but like the thing that you use to run TypeScript without transpiling to JavaScript. Right. But yeah, that's some inconsistency with this.
And I think in TypeScript you need to have emit decorator.
Oh yeah, I forgot to do that. I forgot to show that. So in the TS config, you actually have to have experimental decorator turn on and emit decorator metadata turn on. If I don't have this, you see that I don't have any metadata. All my metadata is gone.
Very cool. Yeah. Awesome.
So I think we can go next to the Automapper in TypeScript. So we know what Automapper is trying to solve, and we know the problem or the limitation of TypeScript. So the Automapper in TypeScript will try to solve the problem, and we'll try to alleviate all of that limitation, not all of that limitation, because it has some language limitation that it cannot bypass, but try to alleviate the pain of implementing an Automapper in TypeScript for you. So I'm going to do with, I'm going to go to this Automapper, Automapper. So my implementation is Automapper/core, and it's actually a part of a monorepo with some packages. I'm going to bump the fonts a little bit. So here I have a core Automapper that's going to handle the mapping configuration and also the mapping operation for you. The classes plugin will handle the what we just do with the decorator and the classes. So it's going to handle the storing the metadata for classes. POJOs or Plano JavaScript objects. This is going to handle the storing mechanism of plan object. So when you in your project, if you don't use classes and you use interfaces of types, you want to use the POJOs. I have an integration for Nest.js. So Automapper is not necessarily just for Nest.js. You can use this in Angular as well, or in any TypeScript project if you think you need an Automapper. But if you want to use this in Nest.js, I have an integration, official integration for Nest.js. And then I have the types. So this is the typing definition for all of the others. So this will always be a dev dependencies. So this is the monorepo, and what I have on here. I'm going to show us a couple of alternatives and a little bit of history. So the first Automapper in TypeScript that I know of, or in JavaScript that I know of, is, I think I have some alternatives in here, is Automapper TypeScript. And this one is by, I don't know how to say his name, Bert. Ludemar. So this one is the first one that I've known of. It's not maintained, as you can see. The last commit is like 3 years ago, more than 3 years ago. It's not maintained. It's not up to date. If this was maintained, I don't think I ever created mine.
Right.
Yep. So this is the first one. This is the OG in the TypeScript space. Next one, you have this Woofy mapper. This one also very similar, but also is not maintained. So next one, you have Morphism. Morphism is a mapper, but the concept is a little bit different. So the concept of Morphism is like the map config that we have. So you just set up a schema, they call schema, that you have a target property. Is that the property that you want on your destination and what you want to map from the source. So basically, earlier in our map config demo, first name would be first name. so you don't have to have a function, things like that. Next one is Object Mapper. I think this one is the oldest one, like 6 years ago. But it's maintained, it's actively maintained, but it's not adhere to the Automapper syntax. So I don't want to use it. And last but not least, this is probably the most popular one, is Class Transformer. Class Transformer, until recently, I thought it solved different problems, but Sir Ken actually showed me that it actually solved the same problem. And I looked into that. I put this on my benchmark, and it's actually very slow because it has a lot of support for decorator, and it runs a lot on metadata. So that's why it's slow. And Class Transformer. So all of these are alternatives. And what you can solve with any of these, you can solve with the Automapper TypeScript. All right. Any question before I go into the demo? I want to show the demo.
I haven't seen any questions yet. I've asked for him like 15 minutes ago. So
Cool.
I think we can just go on. If there's questions, I'll kindly interrupt you.
Okay.
And, we'll go.
So for the demo, I want to. I have an example API right here. That is this is the SpaceX API that returns snake case, probably that we want to map over to camel case. And this is the V3. And we're just gonna map one rocket, and this is the rocket API. So it returns a rocket, it returns the payload, the first stage, all that information. And we would try to map over to a camel case DTO. Excuse me. So I have I prepared some code here. So the first thing we want to do is we actually just copy this JSON. We use a tool called QuickType. I use a tool called QuickType, and I get the interface out of this. So this is the interface. So I copy the interface. I copy all of this. I put it in here and inside of a rocket.ts files, and it changed everything to class. I wanted to demo the classes first. So you have a diameter, ISP, thirst, and stuff like that, models. And on every single property, I attach the Automap decorator. So Automap is the decorator provided by the classes. So if you work with classes built-in, you will have access to the Automap decorator. And this Automap decorator is the storing, the metadata storing mechanism of classes. So on primitives, you just have Automap, 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 Automap. Right? Just keep going, Automap. All of these properties is on that Rocket API. And then if you have a nested model, you will pass in a function that returns that model for Automap. So now Automapper will know that, hey, for probably ISP on engines, the type will be the ISP class. And we just keep going, and everything is the same for thrust. And ultimately, we will get to our rocket. And the rocket will have, you see that diameter, type here, mass, type here, payload, weight. And we're going to map all of this over to our DTO with some tweaks in here and there. So this is, let's assume this is what we get from the API, and we want to map these over to the client side data.
So first you would analyze the structure of your API, and you would create a local copy and basically type your API with these kind of types.
Yeah. Because normally, if you work with a TypeScript project, you're probably going to have some type when you fetch like external API anyway.
Yeah.
Right now, you want to have like some rocket DTO. I call this rocket DTO, but it could be you take the rocket from the SpaceX API, but then you want to map it over to your business model. You want to save some information on that rocket. is not necessarily the same as DTO, but I'm going to just use the DTO here. So here is basically the same thing, the same name with the DTO suffix to the class model name. But you see that I have the casing from snake case to camel case. So we look at the first stage. On the rocket, you will see that we have a snake case of fill amount tons or burn time second. On the DTO, for the first stage DTO, we will have the same name but with a camel case. And the rest is the same. It's just the DTO counterpart. And then if we look at the payloads DTO here, we will have some flatten API. So let's just go down to right here, the height. So if you look back to the rocket, right, the rocket model, you will have the height and the diameter of type diameter. And diameter has meters in feet. So instead of trying to map from diameter to diameter DTO, I love to just flatten that. So I have height meters and height feet. So if you want to have comparison, that's the same thing at height dot meters. But I don't want to have that nested in there, so I just want to flatten with the camel case convention. So height meters, height feet, diameter meters, and diameter feet. And the same thing for mass. I have mass kilogram, I have mass pound. So mass on the rocket is of type mass, and on that it has kilogram and it has pounds. I don't want to have that. I don't want to map from mass to mass DTO. So I just have mass kilogram and mass pounds. And the rest is just the same thing, right? So you have rocket ID in camel case. Over here you have rocket ID in snake case. So rocket ID, rocket name, and rocket type. So this is the models, and this is what we have to prepare. This is what the preparation step. All right. So I'm going to stop there for a second, and then we're going to move on.
Perfect. Yeah, I think one of the interesting things to know is for those of you that worked with Nest.js and used either Swagger or GraphQL, you're probably familiar that you have to annotate your properties with the decorator.
Yeah.
I know from the GraphQL plugin, it's that field. I think for Swagger, it's like the API property decorator. Yep. And this also uses the same syntax. So when it's not a primitive type like string, number, Boolean, or date, you have to pass in a method like we see here on line 195.
Yep.
And
Just real quick to touch on why it is the function and why a lot of people use function, because the function is to prevent circular dependencies or a racing condition when Webpack or any bundler looks at your code. If you just pass in the value like this one, it would just work, but sometimes it would not work because of the racing condition. Like engines DTO might not be loaded when this class is loaded. So the function allows for lazy evaluation.
Very cool.
So,
didn't know that one.
Yeah. So you will see a lot of like metadata-driven library like GraphQL, TypeScript, GraphQL, or the Swagger. We use the type function syntax, and it's the same idea everywhere to prevent racing condition in loading these classes. Right. So we have the rocket, we have the DTO, so like we have all the models needed. The next one is to construct the mapping configuration between the rocket and the rocket DTO. So, and in Automapper, that concept is a mapping profile. The mapping profile will receive a mapper object. This mapper object, we're going to take a look later what it means. But the mapping profile, it doesn't have anything like special. It's just a function. It takes in a mapper object, and it returns nothing. It returns void. So think about it for a second. In your Nest.js application, you usually separate your application into features. So you have like user features, you have a product feature, you have order feature, each feature will have its own like DTOs and its own business models, and you want these profiles to stay close to those models. So you have like separation of concern. So you have like user profile, you have product profile, and you have order profile that you're gonna put all the mapping logic related to those models. So here I have a rocket profile, and in here I create a map from thrust to thrust DTO. So basically this what it means in plain English is, hey, Automapper, I want to create a map from the thrust class to the thrust DTO class, and this is one way only. So this is only create a mapping from thrust to thrust DTO. It's not the other way. It's not two ways. It's just one way from source to destination. And the order that I have this in, like thrust, payloads, payload weight, first stage, second stage, actually matters. If you look at the rocket right here real quick, the rocket depends on first stage and second stage. So the first stage and second stage actually have to be created first before the rocket. Same thing. So the payload weight, I think the payload weight on the second. The payloads on the second. So the second stage has the payloads. So I have to have the payloads mapping ready before I map. I try to create a map for second stage. So the order actually matters here. But then that's pretty much it. You just create all of the map ready for rocket to rocket DTO. And you only do this once. You don't have to do it multiple times. I'm going to talk about these later, but this is the first step.
I think this is the declarative part, right? So you express the desired behavior, the desired outputs, and you don't have to write any custom functions. You just decorate the source, you decorate the target. The Automapper will merge it through thanks to the reflection of the metadata.
Yep. Right. So now we have the profile and we have all the models. We're going to take a look at the actual mapping. So if I have a test, let's call it a test bed right here, is that I have a setup classes method, a helper method that returns me a mapper. It takes in a name, it takes a naming convention. I'm going to talk quickly about a naming convention. So as you can see that we have the source and the destination. The source will be the rocket and the destination is the rocket DTO. So you want to map from source to destination. And you notice already is that the source has the snake case naming convention. And the destination has the camel case naming convention. Let's look into the setup classes. So setup class is just, hey, I want to set up, I want to run the setup and I pass in the class. So the classes comes from Automapper / classes. So Automapper / classes will give you a function called classes. And this is a what I call a plugin initializer. It is a function that takes in the error handler and will return some stuff that the mapper will need. If we have time after the demo, I'm gonna walk you guys through the internal. But basically it's just, hey, it takes in the name, it takes in the plugin initializer, it takes in some naming convention, and I will call create mapper. Create mapper from core, right? You create a mapper from the core and you pass in the plugin that you want to use. So that returns me the mapper with the name, with the naming convention that I want. So basically here it returned me a mapper for classes with these naming conventions, and I think that's all we need to know. Then now you have in my test case, the first thing I want to do is I want to add the profile to this mapper. Without this line, this mapper doesn't really know anything about the rocket mapping. So I have to add profile to it, and you don't call it. It is a function, but you don't call it. You just pass in the function. And add profile internally, we'll call that function and pass in this mapper instance for you. So that if you have another mapper, you don't have conflict between what instance of mapper that you add profile to. Next thing is I have a function called getRocket, and this is just a helper function. I basically copy.
This will be your API call, right?
Yeah, basically that's the API call. Actually, I copied this right here, this JSON right here. I paste it here, and I just do some type assertion to make sure that it TypeScript is happy. So it's just that data directly from the API.
Yeah.
Right? Like those.
Like the reason you do the type insertion here is because you store the JSON object in your code. But if you get it from the API, TypeScript will not complain.
You don't. Yeah, it's just not going to complain. Basically, because we store it as JSON, but if you get it as like, let's say if you like fetch rocket, right? This would return you the rocket type, and you don't have all of these JSON inside your code.
Yeah,
so this is just a helper for me to run the test. Back to this. Cool. So here I have the rocket, and here what I do is just call, hey mapper, I want to map the rocket to rocket DTO, and the source type is rocket. It's a little bit backward, but originally I don't have that, so I try to guess the type of the rocket, of the source object that you pass to map. But because even though actually rocket, even though this is a rocket type, but you see why I have to do this. Now I'm gonna have to run this one. So I'm gonna run debug, and I'm gonna show you what all of these properties and data. So you see that this is the type of rocket, but at runtime it's actually just an object. So if I don't pass in rocket right here, my Automapper doesn't really know what rocket is. It just knows that, hey, it's an object.
Right.
So to prevent that, like to prevent the actual core library to guess what type of the source object is, hey, I just make the API to require you to pass in the source of this type. So you should know when you fetch that data. Right. So the rocket return all of this information, right? And imagine now you have to do this manually, and you want to map these over to your DTO manually. Right, now we have this, and I'm gonna just step over, and we're gonna look at the VM. Step over, it works, and look at the VM. So the VM actually the rocket DTO instance. So if you have some method, on the rocket DTO, those will actually be persisted after map. So that's a cool thing about working with classes. And then you start seeing, now I have all the data. It's like cost per launch. Cost per launch here is in snake case, but then cost per launch here is camel case. Same thing with success rate percentage. Success rate percentage in snake case. Then we look into, let's say now we have some like nested array of different type. So look, we're gonna look at the payload weights. Payload weight is just an object with all of this information. But then over here is a payload weights camel case with the actual instance of the payload weight DTO with the same information that is mapped. And it mapped the correct type as well. So this is string and this is a number. And so that's the nested. And we're gonna look at the flange. So we have a flange of height and diameter. So you see that height and diameter in the rocket is an object with meters and feet. So over here, we would have height meters, height feet, and diameter meters and diameter feet. We're all automatically flattened for you. Right. So that's the thing. The second thing is you see that we have some undefined on here. So the first thing is the landing legs number and landing legs material. And these are actually trying to flatten the landing legs object here, right? With the number and the material, it should be 0 and undefined. But here, it should be 0 and null. Yeah. But here is undefined. Another thing is on the second stage, on the payload DTO, everything in here is undefined. But we actually have data in this payload, right? So here is another case where I try to flatten the composite fairing. So here, I try to flatten the composite fairing height meters, composite fairing height feet, and composite fairing diameter meters, and composite fairing diameter feet. I try to flatten that. But turns out there's some limitation, there's some bugs in the current state of the library that I don't take into account of the top level property name that has the name convention inside of it, but that it has more than 2 words. So landing legs, it has more than 2 words. Composite fairing, it has more than 2 words inside of it. Right. Actually, more than 1 word, I'm sorry. So I did not take that into account. So when I do auto mapping and I try to take the naming convention into account, I just like get rid of all of these. So that's a bug. But we can have a workaround. And I'm going to show you guys a workaround. Now let's get back to the profile. We don't have to do anything for landing legs. We don't have to do anything to the models. But we can use, it is an Automapper, but you can have some custom configuration because it's needed. You never know it's actually needed. And the API is, so when you create a map, and this return a create map fluent function, and on this, you have a for member, and a for member, it takes in, the first thing is a selector. So you want to select what member on the destination. So on Rocket DTL, what member you want to map. So I have a destination, and I want to map the landing legs number. And now you select the member. What you want to do with this member? I want to map from, what? I want to map from, what do you want to map from? You want to map from the source.landinglegs dot number. So now you just establish a mapping configuration for landing legs number. And you are going to do the same thing for the landing legs material. And you see that it has like some type safety here. The landing legs number is a number, and you have to return a number. The landing legs material is a string. You cannot return a number here. You actually have to return the material here, and now it's happy. So I'm going to run again. I'm going to run that again. I'm going to step over this. Now you see that our VM will actually have these populated, so that we don't run into that error with the undefined. So now it's populated. Now the second thing is we had to solve is this payloads DTO. Right. So for the payloads DTO, for the composite fairing, we know that we have the flange of height meters and diameter meters already working in the rocket. So what we can do is on the payloads. So right here, we try to flatten everything here. But what we can do, we can actually create a composite fairing DTO, and on the composite fairing DTO, instead of having height and diameter, we're going to have height meters, height feet, and diameters meters and diameter feet. So on the rocket DTO, that's what I have right here, right? So that, and on the payloads, instead of these 4, now I will have one composite fairing. Composite fairing. It's going to be composite fairing DTO, and it will be of type composite fairing DTO. And you don't have to keep the snake case here. If you look over here, it's snake case, but over here you can actually make that camel case now. All right. So now we have a new DTO. We're going to have to actually map that. So right here on the payloads, on this one right here, before the payloads, because the payloads actually depend on the composite fairing. So we're gonna do that right there. Right, now let's try to map this. Let's try to map this again and see what we get for the payloads. VM. We're gonna look at the VM for the second stage. The payloads. Now the payloads, the composite fairing detail is populated with the right data. We no longer has all of these 4 undefined, but option 1 and option 2 still undefined. Why is that? Because of the same reason with the snake case naming convention. Look at the payloads. It's actually has two parts, option and 1. So for those, now we actually have to like put in some configuration manually. So back to Rocket profile, I have this right here. That will be right there. So now on the mapping of payloads to payloads detail, I have to have the option 1. I want to map from option 1 right here, and same thing for option 2. Now it should be mapped correctly. So back to the VM. Second stage, payloads. Now you see that option 1 is mapped correctly. One last thing is the KN right here. The KN is not a naming convention. It's actually a unit. But Automapper thing, it is a naming convention. So I don't know if I can do anything about this in the library, because I cannot possibly know all of the different unit in the Word. So for KN, we're going to have to do some manual mapping. So now back to the profile. So for the first, we're going to just do this. So now we say, hey, for KN, just map directly from KN. And this is actually the complete profile for the Rocket to have all of the information mapped for you. Let's do that one more time. Yep, now everything is populated correctly. So you have first of KN31. On the payloads is correct. The engines is correct. Propellant is the same thing with the option 1 and option 2. So you have to manually map these. But yeah, like the thrust sea level, thrust vacuum, all of these is not flattened, but like it takes the naming convention into consideration.
Very cool. I can imagine this saves a lot of work when you convert it.
Yep.
When you wanna redo the work. And for those nerds that are curious, KN is kilonewton. So 1,000 newtons is 1 KN. But that's totally out of the Automapper range. But yeah, it was funny to bring on there. So very cool, very cool. So a very convention-driven and declarative way to convert your model from one shape or your data from one shape to another. I think this is a super clean implementation. I have done, like recently, like maybe 6 months ago, I've worked with an API, the Infusionsoft API, and it had underscored fields, and I didn't know that Automapper could do this. And I created quite a messy set of converters because it was quick and dirty, and I had to reinvent it, and I came up with some convention. And while it works, I mean, I even added some tests to make sure that it works. It's not at all pretty, and it's neither is it reusable. So I'm definitely, when I'm touching that project again, definitely going to use this this Automapper for it.
Cool. Yeah, and that's it. That's the whole thing about Automapper. Of course, for like for this one, you can have like extends. You can extend from different mapping. So this is to work with inheritance in TypeScript. So if you have like a base class that always map created date, updated date, and stuff like that, you can have like a base mapping, and you will have all of these extend from that base mapping. And one more thing is this create map actually return a create map fluent function. So you can always have a fluent function, right? And you can actually wrap these with that. You can do some very, very reusable stuff with this. And every logic of your mapping will stay outside of your models.
Very cool. Yeah, it's totally on the side. And I can even see, like, if you want to have, like, let's say I have an API and I want to deliver an SDK package, that you can have some sort of mapper.
Oh yeah.
Mapper config shipping with it. So like, okay.
Yep.
Just use this config and
yeah, absolutely. Absolutely, yeah.
Very cool. So I still don't see any questions. I think it's all super clear. For me, it's all clear. I really like how you explained it. Is there any more thing on your slides that you had prepared? Or
I think that's it. And it's just now Q&A, and then if we have time, we at 1 hour mark, but I think we still have some time left. And I can walk you guys through how the Automap decorator actually stored metadata.
So this is something I'm personally super interested in. And with regards to the time, I have weekends as of now, so I can go until like Monday. But I know you have a call in 1 hour from now.
Yeah.
But let's see if we can do something like maybe half an hour-ish.
Absolutely, yeah. Let's do that. So let's just get back to this. Right, let's get back to this. I'm going to put a breakpoint on the create map to see how it actually works. All right, so because you know that create map will always be the first one you're going to do, and this will always run once before your app actually start. If you work in a Nest.js project, I have an Automapper profile. If I can find it, Automapper profile. There we go. I have an Automapper profile that when you have your profile in your Nest.js application, you're actually going to have to extend this. And when this get initialized by Nest.js dependency injection, I'm going to call the add profile for you. So it will always be first. All right. So that's the first thing. So I'm going to run the debugger now. It's going to stop at the grade map. And just so you know, we stop here. So all of this mapping has already been created. Now I'm going to step into that create map. So create map is a method on the mapper. So it's a return type of the create mapper here. And here I check because create map can text in the naming convention as well. So if you have like a specific pair of models that do not share the same naming conventions as the global, then you can pass in the name conventions to override the global one. But if you don't pass in any, I'm going to use the global. So this is the check right here. Use the global ones. So because I have the name conventions on the global, then I'm gonna assign it. And here is the work of the plugin. So you see that the plugin is to get the plugin from the plugin initializer, pass in the error handler, so that the plugin will have the universal error handler that used across the mapper. So on the plugin, it has the initialize mapping. So this is the responsibility of a plugin to initialize the mapping because it stores the metadata. So I'm going to step in here. And now we're inside of the classes plugin. We know the classes plugin right here. And the classes plugin have 3 storages. One is the metadata storage, the class mapping storage, and the instance storage. So inside of initialize mapping, I just check, hey, if I already have this mapping, I don't want to do anything. I just say throw the error. But in this case, I don't have the rocket to rocket detail yet. Then it's gonna skip over. And here is where I explore the metadata. And before I jump into that method, I'm gonna show the Automap decorator. So Automap decorator. Oops. Just do that. So Automap decorator will tell is a property decorator, and what it does is actually just call reflect metadata and define some metadata on this target. So imagine, I'm going to just put some code here. Imagine if I have a class of food, and I have food string bar number here. So what Automap does is it will try to save for food class. It will have an array of metadata, and each of these will have the property name and the type function for this property name. So for this one, it's going to be string, right? And that's an array, and this is another array. Type function is going to be string right there. So what Automap does is it will create, or will try to come up with this with the reflect metadata. So at this point, all Automap does is just try to attach information on the reflect metadata. I don't have any information yet in my classes plugin. So let's get back to the explore metadata. So if I go to this one, So I pass in all the models. So I call create map with rocket and rocket DTO. So my models will be rocket and rocket DTO. And for each model, I'm going to grab the metadata from reflect of that model. And I'm just going to loop it over. And now I'm going to use the metadata on reflection and then add that to my storage. Now I have in my runtime, my classes plugin have the information about the metadata. So that's explore metadata. I'm gonna get out of here. Oops, let's just rerun it because I hit the wrong button. So let's rerun it real quick.
Probably sneaked in some error somewhere.
Automap decorator. What the hell?
Command C a few times. There you go.
All right, so let's go to create map. Let's go to initialize mapping. And we stop at explore metadata. Now we're going to step over it. So at this point, my metadata storage, let's look into that. My metadata storage, in the storage, it is a weak map, and it has all of the information. And I use the actual class as the unique key for each one. So all of this has been saved in the metadata. So if we look at rocket, it will have all of that information for me. So it has all the fields on the rocket. And if you look at the rocket DTO, we'll have the same thing. So now I have the metadata of rocket and the rocket DTO. So the next thing is I want to run instantiate. So instantiate is essentially the same as like new rocket DTO, but I'm going to attach metadata on the metadata on it. So let's jump over this and look at the destination instance. You see that the rocket DTO, the instance, is populated with all the property instead of just new rocket DTO. So even the nested property has been initialized. All of that has been initialized for me. If I missed anything in here, then I'm gonna have to do that with the for member.
Right. Yeah.
So that the destination instance, I'm gonna do the same for the source instance because I need both to map over and create the inertial mapping for these. So let's look into this instantiate method. So instantiate just, hey, what metadata for this one, for this guy. So for class rocket, I have 23 metadata. Now I grab the instance. So you see that I just called a new model here to get my instance, which is an empty rocket instance right there. And if it's empty, then it just return the instance. If not, then it start looping. I start looping over it. All right, so just grab the key, grab the meta, and try to, hey, if it's primitive, it's a date. If it is array, if it is the object, blah, 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 all of this is just try to get, step out.
Trying to find the type.
Get the source instance with all of the properties populated. And then here, just getting to some JavaScript stuff. I try to get the prototype of this, if there's any prototype, if the rocket extends some other classes and stuff like that. Now, the core, Automapper core, actually provide a helper called create inertial mapping that you don't have to do anything else. You just have to provide the instance that has been populated, the destination instance that has been populated, and the constructible. So what is the nested constructible? So not nested constructible is all of the property that has nested model. So like for height, it's going to be diameter. So I keep track of these inside of an array. So masses, it will have a nested of mass. So when I map to the mass property, I know that it has the type of mass. And I think that's pretty much it. And if you go to create initial mapping, that's just some function for this. And create initial mapping is create the mapping. And then it will loop over, it will try to loop over all the, let's see. Yeah, it will try to loop over the destination path. So I have my destination object here with all of these properties that allows me to get the path of all of that inside an array, which is right here. So I was able to get that because of the metadata. Without the metadata, my my object is empty, so I cannot get the path. So now I have the path. I'm going to loop over the path, look for the same property on the source, and try to work in the name convention and stuff like that, and try to get my mapping. So that's the whole thing inside of this loop. And I don't think we should be able to, we can go through here that I can explain clearly for everyone. Like ultimately, you're going to get to the mapping and I'm going to push each destination onto the mapping properties and with the map initialize. And yeah, and that's pretty much it, bro.
Very cool. Yeah, very cool. And can you explain a little bit? So I see you do the count backwards. So you do I minus.
Oh yeah. Yep. So with this one, so when you have a loop that you don't really care about the order of the loop, or you have you have a loops once, and then somewhere else you have another loop, but you care about the order, but you do the while loop reverse twice, then you have the right order. So this is what I do here. I have while across the library, but I know exactly where I need the while loop. Why do I need the while loop here? The first thing is you don't need the index property. The second thing is basically for the for loop, you need the index, you need the length.
Yeah.
And you need the length, right? So I'm gonna write it right here. For let e, right? Let e equal 0, and then you could do e less than destination path dot length e plus plus. So this is the original for loop, and for each loop, this destination path dot length is accessed again. So it's another operation that just JavaScript has to do. You can cache the length by having a length here and do this.
Yeah.
Right. So now you cache the length. So each loop, the destination path dot length will not be recalculated.
Yeah.
And then, so but still, you still have to have index. You still have to have length. And you still have to have this calculation right here. With the while loop, with this one, when you get to the last index, JavaScript still has to compare the last index with the length, and then it exits the for loop. So let's say if length is like 400, and you add index 399, and then you finish the loop. And then you get to I11, I plus plus. Now this gets to 400, and then JavaScript still has to compare 400 with the length 400, and then exit the loop. But with the while loop, you actually decrement it. So let's see right here, you have the length of 400, but then because the length 400, so the last index would be 399. So you're going to start at the last index, and when the index gets to 1, when the index gets to 1, and then I minus minus will be 0,
which is false.
Yeah, will be 0. But I minus minus. So actually, when the while loop access I minus minus at 1, it will still run because the I minus minus will give you the value after.
Yeah.
So
but
it's just
the reason it stops is that you stop at 0 and 0 returns to falsy, which makes you stop the while at that point. Yeah.
So this way, you only have one variable, so it's memory efficient. You don't have to compare against the length, and you have one less operation.
Right. Yeah. Very cool.
So that's the while loop, and that's one optimization that I have to do. I've done for this library, and since we get on that, I'm going to get to the mapping, or I want to get to these mapping, or the models inside of the library. You can see that I use array only.
Yeah.
I don't have like
no objects.
Yep, no objects. It's only have array. And if we look at the typings, it's actually array. And I love TypeScript 4.1. It gives me the name tuple, so that now I can name these for documentation purposes. So these are array, and then I have mapping property. This is also an array, and mapping transformation. This is also an array. Why do I do that? So JavaScript V8, when you have an object, let's say when you have an object, ID, first name, last name, when you have an object like this, V8 actually convert your object into an array. It's going to convert your object into an array, and the first item in this array is called a class ID. Then you're going to have the ID value here and the first name value here. And what the class IDs is, I don't remember class IDs is an object on array, but it actually stored, let's say the ID will be the index 1. The first name will be the index of 2. So when JavaScript when V8 access your data, it will actually just do an array, right, of the class ID of like 1. This is your ID or something like that. I forgot like ID, something like that.
I can tell you as well, the thing I'm just sharing is a great talk from Mishko that talks about this optimization.
That talk about this actions exactly. And by having all of my models as array, I bypass this for you. I bypass JavaScript having to convert your object into array. So that's another optimization thing.
And this is mostly internal anyway, right? So this is not something.
Yeah, it's internal. It's internal. Because when the public API is an object.
Yeah. Love it. Very cool.
Yeah, and I think before we go to another Q&A, if anybody has any question, I actually have a bench, ng.nar.github. There we go. I actually have a benchmark here that I like to show. I have a different implementation of mapping. So here, the map is. This map is the original Automapper that I wrote, Morphism, class transformer, and this is the Automapper / classes, and this is the Automapper POJOs. And we can run all of them, and the operation will map 10,000 items, and I map it 5 times and take the average. And it's kind of slow because of class transformer, and you can see why here in a minute.
This kind of blocks your main UI thread for a second, so takes a little bit of patience. But is this also where you find out the performance issues? Is this where you find out any optimizations, or?
I implement the optimization before I run the bench. So here you can see that the original mapper run 10,000 items, with at 100 milliseconds. Morphism is a little bit slower. The class transformer takes 2.3 seconds for 10,000 items. So it's the slowest. And then for Automapper classes is a little bit faster than the original Automapper. And then POJOs is a little bit slower. So this is the bench. So it's like running this bench. This benchmark makes me happy because I know my optimization actually has effect here. So yeah.
Very cool. I'm super impressed by the work of this project. We did do actually another talk. First time you were on BLS, we actually talked about this, and yeah, I think it's super nice. I wish I knew this tool before, but I didn't. I'm definitely going to use it. Do you use it at this point in any of your projects?
So this is the Postgres project. I'm going to run npm install here while we talk about it. This is the project that I bring onto your talk to talk about Automapper. Yesterday, I updated it to the latest version of Automapper. So right here, I used Automapper mono repo here, and then I changed my mappings to use the new Automapper profile. With this, you can actually have like services injected into your profile to run to have some logic for your mapping. So that injectable now, and the models, everything stays the same except for the profile and except for how you initialize the mapping. So it's just for root now, and it takes in the classes as the plugin, and everything stays the same, and everything still works. I'm going to run the project, and we'll see. Let's see if it works now. So I'm going to stop this, guys. I'm going to run the Postgres one.
Docker not having its day.
Because these guys still running. I want to stop those. Now I can actually start this one. There we go. Now I have the database running. I can run my API and run API serve. Going.
Yep, letting TypeScript inspect a few models, store some metadata. Now we know why TypeScript takes some time to compile.
Yep. All right, now we're gonna use the Swagger UI here. So I'm gonna log in, try it out. Part 2456, log in. All right, I have my token.
Job token.
Yep. Now go to my post. I'm gonna just grab all the post. Authorize and try it out. Execute. And this is my post. And actually, these are actually post VM or post DTO. As you can see, the author right here is all mapped, and I can show that in the code. If we look into the post profile, we see that we map from post to post DTO, and on the DTO we have the user information, and on the post we have user. So it's going to map from user to user information automatically. And we can look at the user profile, and this is where I create that map. So everything just works, and you can have a separation of concern right here. I have post model, I have post profile, I have user model, I have user profile, and
very cool.
It just works.
Awesome, super nice. Yeah. I'm deeply impressed. Also, this is a great resource for me when I go back to writing a decorator, which at some point I inevitably will. I'm definitely going to check this out and check the source here. But yeah, super great. I haven't seen any questions yet, so I think it's everything clear. We do have viewers. We're still online, so I think it's just super clear. And with that, if you have any other things, so yeah, check out the. Let me bring this in the screen.
If you can bring up the docs. Yeah, that too. GitHub is fine.
Yeah, this is the repo, and then the docs is automapperts.netlify. So,
oh, and you know what we have to do now? We're gonna release it. No, I have to fix some bugs. I have to fix the bugs first.
Yeah, so
Yeah. We're actually planning to release official the V1 version 1 officially on stream, but because I ran into those bugs, I'm gonna have to fix it first.
Yeah, very cool. And yeah, so the documentation can be found here, automapperts.netlify.app. And yeah, awesome. Thanks a lot, Ciao, for being on here. It was an honor to have you. First show in 2021. So
Yeah, thanks.
Super great. Hope to see you all soon. And with that, we're going to wrap it up. Thank you, everybody, so much. I hope you'll have a great weekend and see you all later. Bye-bye.
Bye.